right, we are on our last section of indicator 22, which is the Pythagorean Theorem. So I just want to do a quick review of the Pythagorean Theorem. So first of all, it only works with right triangles, which is a triangle that has a 90-degree angle in it. And we have different parts of the triangle that make this work. We always label our sides that make the right angle, A and B, we call those legs. And then C is opposite that right angle, that diagonal, that we always call the hypotenuse. So A and B, the legs, it actually doesn't matter which one you call A and which one you call B. But the Pythagorean theorem is a squared plus b squared equals c squared. And I know that you did this a lot in middle school, so I'm hoping that that's familiar. If you feel like after the lesson you need more practice, just shoot me an email. I will be available, especially in the afternoon, to do a Google Meet with you. So we are, hang on, I'm just making sure that that light shows up. I apologize. Well, that's not it. All right, so this is it. So we have the Pythagorean theorem. So we are going to find missing sides of the triangle today, and if they're not perfect squares, we will be doing some simplifying radicals. So the first few, I'm just going to give you the values of A, B, and C. One of them will be unknown. So let's just say that A is 6 and B is 8, and we want to find out what C is. So we are looking for that hypotenuse. So we just plug in what we know into a squared plus b squared equals c squared. In this case, A is 6, B is 8, and C is unknown, so that just stays c squared. Now we got to simplify. 6 squared is 36, 8 squared is 64. We always have to do exponents before we add. So we've done our exponents, now we got to add those together. 36 plus 64 is 100. So we are trying to find out what number squared gives us 100. And I'm sure you guys can probably tell me 10 squared equals 100. But the reason why we do that, if you want to know what number squared gives you this number, we actually take the square root of that number. So to get that variable by itself, in all cases today we will be simplifying that square root. This one was a perfect square, so C is 10. Now let's do another one like that, and I'm going to just scoot over. This time let's go A is 4. Let's just say we don't know what B is, and C is 12. So we are still going to do the quadratic formula, but this time our B value is unknown. So we're still going to plug into our formula. We know A is 4, and we know C is 12. So 4 squared plus B squared is 12 squared. Now we know 4 squared is 16. And we have our B squared. 12 squared is 144. So we're trying to get B by itself, so we have to subtract that 16 over. And we can subtract and we get B squared equals 128. Now we could try, but there is not a whole number that when you square it you get 128. So we want to know what is that square root of 128. The opposite of a square is a square root. So we want to know what that is, so we do have to simplify, or as we've coined the term caking. Let's just look at 128. We divide it by 2, we get 64. We divide by 2 again, and we get 32. Divide by 2 again, we get 16. Divide by 2 again, and we get 8. Divide by 2 again, and we get 4. And finally, we're dividing by 2 all the way up to 1. So we've got lots of 2's here. And we are looking for pairs, so we have 1, 2, 3 pairs of 2's on the outside. So 2 times 2 times 2 with 1 2 left over. So our b value today for this one would be 8 root 2. So if you are missing a side, you are going to have to do some subtraction. If you're missing the hypotenuse, it's a little bit simpler. Let's do a couple more, and this time I'm actually going to draw a triangle for you. Alright, so we are missing, you have to determine if you're missing a leg or a hypotenuse. In this case, we are missing a leg. Now, it does not matter on the legs which one A is and which one is B, but we definitely need to know which one is C. And in this case, the hypotenuse is your C. So you are going to set up 8 squared, and I'm going to call this one B because I listed 8 squared plus B squared equals 15 squared. We know 8 squared is 64. And we know 15 squared is 225. So then we can get those calculators out, and we can take 225 minus 64. And we get b squared equals 161. Oh, I marked it too soon, didn't I? So we could simplify this. Made a mistake. I circled too soon. Now 161 is divisible by 7, and you get 23. Now 23 is a prime number. So on this one, we do not have any pairs. So this means we're done. So this one is the good answer. So we know b squared is 161. We tried to simplify it. There's no pairs to simplify it, so we just leave it as the square root of 161. All right, I've got one more. So we've got the right angle here, and we're going to say that, let's say this side is the square root of 25, and this side is the square root of 45, and we want to know what this is. So in this case, we have been given two sides, and we got to figure out what we're missing.
Mr. Cross and Mr. Miller, if you're still in the building, could you please come to the office?
Okay, so we are looking for these. Now these two sides make the right angle, so these are legs. So again, it doesn't matter which one you call which. I'm just calling that one on the left A and the one on the right B. We are looking for C. So we are going to set up the square root of 25 squared plus the square root of 45 squared equals C squared. Now, square roots and squares are opposites of each other. So I'll show you guys on the calculator. Hopefully you guys can see this. The square root of 25, or so 25 squared is 625. So we could take 25 squared and get 625 and then take the square root of that. You go back to 25. A square root and a square are inverses of each other, so they undo. So if you have on the same number a square and a square root, that is just 25. Same thing here, that's just 45 equals C squared. So we're adding 25 and 45 together to give us 70. Now 70 is not a perfect square. There's not a number squared that equals 70, but we can try to find the square root or simplify that. Divide that by 2 and I get 35. Divide that by 2, oh, I can't divide that by 2. I divide it by 5 and I get 7. Divide by 7, I get 1. I do not have any pairs. So on this one, this is my simplified answer. Now if I had pairs, I definitely would want to do that. So sometimes you will have whole numbers, sometimes you will have you will have to cake those. It all depends on the day. And if you have any questions about this at all, don't hesitate to email me and we can do a Google Meet. I hope you guys have a great day, and I will see you all tomorrow.